Welcome to the another video of rational number, and this is the last video of our chapter 1. In previous video we completed exercise 1.2. Now we are going to start examples. Okay, so let's start examples. So first example number 1. So first example is this: find 3 by 7 plus minus 6 by 11 plus minus 8 by 21 plus 5 by 22. So we have to find the final value of this addition of rational numbers. Let's recall how we add and subtract any two rational numbers. Before that, let's recall a rule of multiplication of negative and positive integer rational numbers. Okay, then so first thing is that if we multiply one positive number and one negative number, then our answer of multiplication is always negative. Okay, one positive, one negative, and if we multiply them, then we will have negative answer. Now if we have two negative numbers and we multiply, then our answer will be positive. Okay, in multiplication, multiplication of two negative numbers always any type of number. Multiplication of negative number, two negative number is positive. Multiplication of one positive and one negative number is always negative. So this is for multiplication. Okay, what is that? If we multiply okay, one negative and one positive, then our answer will be negative. If we multiply two negative numbers, then it is positive. Okay, yes. And in addition, if we have if we have one positive, one negative, then we do subtraction. We subtract smaller digit from bigger digit. And if our smaller digit our bigger digit have negative sign, then our answer will be negative. Okay, if our bigger digit has positive, okay, I am talking about digit, not a number. Digit means 0 to 9. Okay, 0 to 9. If our bigger digit, okay, not 0 to 9, but only number, not concerned about any type of sign, positive or negative. Okay, only see, if whenever I say digit, then you have to see only number without any type of sign. Okay, as example, I write 49 and minus 48. So if I say which is bigger digit, so bigger digit is 49. Okay, you have to see only digits. Okay, let's say both are minus, then which is bigger digit. So digit is 49, but what which is bigger number, bigger than other? So what? 48. Okay, 48 is bigger than minus 14. Minus 48 is bigger than minus 49. Okay, but for digit, if we concern about digit, then we do not see sign. Okay, we only see numbers, 4948. Okay, so if we add one negative, one positive number, then we subtract smaller digit from bigger one. And if bigger digit is negative, then if bigger digit have negative sign, then our answer will negative. If not, then positive. If we add two negative number, then we add them, and our answer will be negative. Okay, but in multiplication, if we multiply two negative number, then our answer will positive. Okay, so this thing we have to remember, okay, for this kind of questions. So first, let's solve this. So this is 3 by 7 now. Okay, and another thing after this, that for addition and subtraction we must have rational numbers with equal denominators. Okay, if our denominators of rational number are same, then only we can add or subtract any two rational number. So first we make denominators equal, and after then we add or subtract our numerators. Okay, we do not subtract our denominators, we make denominator same and we subtract and add our numerator. So first we remove this bracket. Okay, if we remove this bracket, then the sign will be changed. Okay, let's see. Okay, this is plus into minus. Okay, plus into minus, then it is minus. Okay, minus 6 by 11. Whenever you remove bracket and outside of bracket if there is negative sign, then final sign will be changed. Okay, no, outside or inside. If outside is plus and inside is minus, then if you remove this bracket, then final sign will be minus. Here same, minus, plus minus, minus. If you have minus sign here, then minus plus. Okay, minus plus. Now plus 5 by 22. Okay, this is our first step. Now we make denominator same. So for that, see, for denominator, for making denominator same, two things we can do. First thing, we can do cross product, or we can take LCM. So if we do not know the LCM of this numbers, okay, or we have no time to find LCM of this number, so we can do cross product. So for cross products, we make pair of numbers. We have four rational number, then we can make two pair. First pair is this and first pair of this. Okay, so let's do cross product. 11 into 3, 33. Okay, there is another way to do this. Okay, I will show you. 33 minus 7 into 6, 42. 7 into 11, 77. Now here this minus sign is assigned to this 8. Okay, so we can write as minus 8 by 20. Okay, these are basic things that you have to remember or you have to understand. Okay, it is not major step. Okay, this is simple thing. Okay, if you multiply 8 by 22, then the numerator of this rational number is will be negative. Okay, now 21 into 5, 5 into 5, 5 into 1, 5, 5 2s are 10, and okay, sorry for that mistake. Okay, so yes, I was writing this like, okay, minus 8 by 21 plus 5 by 22. Now 33 minus 42, 77. Now we multiply. So 8 into 22, 8 into 2, 16. 1 above 2. 8 into 2, 16. 16 plus 1, 17. So this is minus by 21. Plus 21 into 5, 5, 10, 0, 5, and 21 into 22. Now 33 minus 42 by 77. Okay, plus. Now you have 1, okay, same thing, 105, change the order. Now multiply this 2. Okay, so 21 into 22. Now let's make this thing simple. 21 into 22, 21. Factorize this 22. 11 into 2. Okay, whenever you multiply 11 with any 2-digit number, 21 is 2-digit number. Whenever you multiply 2-digit number with 11, then use one trick. Okay, so answer of multiplication of with multiplication 11, then what you do is multiply this array, add it to this digit 2 and 1, 2 plus 1 3, and add in between 2 and 1. So this is answer. This is answer of multiplication 2 1 with 11. Okay, and then you do not require to do whole multiplication. Remember, whenever you multiply any 2-digit number, okay, only 2-digit number with 11, then you can use this trick. Okay, simply if you multiply 21 with 11, then add this 2-digit and add between 2 and 1. Then this 231 is your answer of multiplication with 11. So here 231, this is answer of this 2 and into 2, and now you can easily multiply 2 with this number. So 2 into 2, 2 into 3, 6, 2 into 2, 4. Okay, now let's write answer of this subtraction. Now subtract, see here, 1 positive, 1 negative, then we subtract smaller digit from bigger digit. Okay, here we subtract 33 from 42. So subtract 42 minus 33 is that 12 minus 3, 12 11 12, 9, 12 11 10. Okay, and okay, so this is 9, and our bigger digit has negative sign, so this is negative 77. Same thing here, 1 positive, 1 negative, then we subtract 105 from 176. So 6 minus 5, 1, 7 minus 0, 7, 1 minus 1, 0, and our answer will negative because our bigger digit have negative sign, minus 462. Now you have a big task. If you want to do cross product, you can do, but think something that by which number you multiply with 77 and then you get 462. So count let. With 1 not, with 2 not, because with 2 7 to the 4, 14, and we have 4, no, 3 no, 4 no, 5 no, 6. If we multiply by 6, then our denominator will become same. Okay, multiply 77 with 6, 7 6 are 42, and 7 6 are 42 plus 4 46. Okay, 77 into 6, this 6 into 7 42, 42 plus 4 46. So let's, and this 9 into 6 54, this is 40. Okay, if you do cross product, then our multiplication will become too big. This plus minus minus. Now we have finally same denominator though, so we can add or subtract our numerator. Let's write as like, now we have two negative numbers, then we add this 2. So add this, 4 into 1 5, 5 into 7 12, and our answer will be negative because we have two negative numbers in addition. Okay, so this is our answer of this question. Okay, there is one another trick to do this, not trick, different way to do this. Okay, but our main what can say, main concept is same, that you have if you want to add or subtract any two rational number, then you have to make equal denominators. Okay, so let's see another way how to solve this question. So for different way, what we will do is that, let's write again this question. Okay, plus minus minus 6 by 11 plus into minus plus 5 by 22. Now what we do is not we make a randomly pair, we observe denominators. Here 7, 11, 21, 22, and we can see here. Okay, you thought that here we can see that we can convert 7 into 21 by multiply by 3 at numerator and denominator. So denominators of these two will become same, and we also convert this 11 into 22. Okay, if we multiply and divide by 2, then denominators of these two numbers will become same. So let's do that. Okay, 3 into, okay, convert this 7 into 21. So for that we multiply and add by, multiply and divide by 3. 7 into 3. Now for this 11, we multiply and divide by 2. Okay, our final our main number can't be changed. Okay, our given number is 3 by 7. If you if you divide and multiply, then you have to remember our given number will not be changed. Okay, can't be changed. 11 into 2, 8 by 21. Okay, don't multiply and divide by 3 and 2 here. Okay, only multiply and divide by 3 and 2 for these two numbers. Okay, now 3 into 3, 9, 21, 12, 22, 8 by 21, 5 by 22. Now gather rational numbers with equal denominators. So see here, this, okay, this and this have equal denominators. So write at one after one. Now this rational number and this rational number have equal denominator. Then write it together. 5 minus 22. So see, now the things become simple. Okay, 9 minus 8, 1. So 1 minus 21. And here, if plus minus 12, 5 and 22. 1 minus 21. Here, 1 negative, 1 positive, then we subtract smaller digit from bigger digit. So subtract 5 minus 5 from 12. So 12 minus 5, 7. And our bigger digit has negative sign. So our answer will be negative. So answer is minus 7 by 22. And here you can't convert 21 into 22 and 22 into 21. Okay, as we did previously in the starting of the sum. Okay, for that whether we have to take LCM of this or we can do cross product. So here we do cross product because our multiplication of this denominator and numerator is looking simple. So 1 into 22 is 22. Here plus minus minus. 21 into 7, 7. 7 2s are 40 by 21 into 22. Okay, subtract this 22 by from 147. So answer is minus 125 because our bigger digit has minus sign. Let's do that trick again. 21 into 22. Factorize this 22 with 11. So 11 into 2 is 22. Now multiply this 2. So What is the answer? Think. Answer is yes. Add this 2 and 2 plus 1 3 and write 3 in between 2 and 1. So this is the answer of multiplication 21 into 1 1. So this is 2 3 1 into 2. Now you can simply multiply these 2 6 4. Then see, our process is different but our answer is same. Okay, so you can do this sum as like this or previous. Okay, now third way. Okay, there is third way also by using commutativity and associativity. Okay, to make this easier, let's do that also. Okay, and I'm saying that this is not a last video. After that 2-3 video will come. Okay, another video will come for completing these examples. Okay, so let's see third way, how to use commutativity and associativity in this sum. First, let's recall associativity and commutativity. Okay, if we have, let's say commutativity, if we have A, B as two rational number, then if we add this, then if we change the order, then our answer will not change. Okay, A plus B is equal to B plus A. If we subtract A minus B, then it is not equal to B minus A. Okay, if we multiply this, then it is equal to B into A. Then as like if we divide A by B, it is not equal to if we divide B by A. Okay, change the order. So for subtraction and division, the commutative property does not hold. Okay, for any number. But in multiplication, in addition and multiplication, commutativity property holds. Now let's talk about associativity. What is let's see the associativity property. If we have three rational number, then associativity property is A into B plus C is equal to okay, is not like that. It is A plus B plus C is equal to A plus B plus C. Okay, meaning of this bracket is add first this, after that with A. Here add this first this, and after that add C. Okay, so this is associative property. So using this, in next video we will see third way of doing that sum. Okay, ultimately process is same, make denominator same, but for easiness we will use this into that example number 1. So stay tuned for examples. Okay, I again say this is not a last video. Okay, because I said in start of the video that this is last video, but this is not. Okay, so stay tuned for rational numbers.